Hello, everyone. I am Javier Ortiz. I am your mentor throughout this program, Data Engineering Nano Degree by Udacity. So I'm really happy to talk to you again, guys. And before we start with today's webinar, just a couple of reminders. Our study group resides here at Slack DND session 963. So make sure each week to check it out, since every Tuesday I post the weekly roundup where I specify the lessons they have to go over this week to be on schedule, and you schedule events such as this one. And here you can find the Calendly link, or you can schedule a one-on-one meeting with me where we can go over your queries and specify a personalized learning plan for you. All right. Also, in these groups, I will be posting the recordings of these webinars, and you should be also receiving them through email by a systematized by an automatic sender from Udacity. All right. So those were the reminders. And regarding the schedule, just this week, make sure to work any lessons you haven't finished from data lakes so that you can start working on the project, which is due by the end of the month. All right. With that being said, let's start today's webinar. Now, today's webinar, I'll be walking you through the data lakes project. So hopefully you've been watching the lessons and making some progress through them, and you will understand most of what we'll talk about today. All right, so the project, once again, you're a music streaming startup, Sparkify, and it says that you have your user base and song database, and you want to move them from the data warehouse to a data lake. Now the data resides in S3, that's the way that their warehouse, and a directory of JSON logs user activity on the app, directory JSON metadata on the songs in their app. So you're tasked with building an ETL pipeline that extracts the data from S3 processes using Spark and loads the data back into S3 as a set of dimensional tables. This will allow their analytics team to continue finding insights in what songs their users are listening to. All right, so basically they have their data in an S3. You're going to extract it from that same S3. You're going to transform it and the star schema, set it up for analytics, and then you're going to load it back to the S3 for the analytics team to use it. All right, and that's right. So we'll deploy the Spark process and a cluster using AWS. Let's get to know our data sets. So we have the song data, which resides here in this S3, and we have the log data also here in the Udacity DND. Each one in a different folder, song data and log data. All right. Song data is really important that you understand the path because you're going to use it. So inside the Udacity DND, you're inside the song data, then you have one folder, another folder, and then you find your file, all right? So you have to go inside song data, then 3 levels down, and then you will find the file. And these are the sort of data that you will be find in each file. Num songs, artist ID, artist latitude, longitude, location, name, song ID, title, duration, and year. That's regarding songs. Now about log dataset. All right, so they follow a similar path. They're inside the DND, Udacity DND folder, and then inside log data, then 1, 2, 2 levels down, and then you'll find the file. And these are the sort of columns you can find: artist, auth, first name, gender, anonymous session, last name, level, location, method, page, registration, session ID, song, status, TS, user agent, user ID. So it's really important that now that we're going to see the schema that we're going to build, you start thinking of where would be the correct place, which file would be the correct one to get certain information. So if I'm trying to build a songs table and I'm looking for the title and the song ID, well, these song data files are the places where that will look for them. And if I'm looking for certain user data to build my table, I will look for those columns in these files. So this is the reason why we need to get to know these two files. For some places, it's a little bit trickier because we need information for both files. All right, so they show you the sort of star schema they would like to have. Once you've extracted the data from the S3, transform it, and load it back into these, back to the S3, but having this star schema form. All right, so we have a song place. They care about the ones that page says next song because that means they're playing songs. And these are the sort of columns that you would like the song place table to have. Users with the sort of columns that you have. And here's what I meant. What I meant when I said start thinking of the sort of columns you will use and where would you get that info. So for example, for users, user ID, first name, last name, gender, and level, this is all information that comes from the log files. But this is information that will come from a song file. So you need to start thinking of where you're going to find this information. All right. This says that you have an etl.py, which basically runs the whole thing. You have a dl.cfg, which contains your AWS credentials, and a README file that you need to discuss your process and your decisions. And here is just like what the README file needs to have. All right. And a reminder, do not include your AWS access keys in your code when sharing this project because you will be granting access to your AWS account, which we don't have bad intentions, but I mean, it's just a good practice to keep early on, not having your data fall on the wrong hands. All right. So the whole project resides in this workspace. You're welcome to work it locally, but I mean, it's really easy here and it works the same as in your computer. So I would suggest just work here. And once you're done, you can submit your project with this button that says submit project. All right, so the first thing that I would do is just get done with the dls.cfg. So you can go to AWS and create a user and a role if you don't have one. But I think most of you already have one because we have used them in previous projects. So I am, and from here I can just create a role. You create the role, and at the end of when you create the role, it will, I mean, let's go over it. Create a role, then I'm going to, sorry, it was a user. Sorry, an IAM user. Yes, this is the thing that I would like to use. So add user, then I don't know, let's say just for the data lakes user, then programmatic access, permissions, attach existing policies directly. You can give it access to S3, like read only, or you can give it full access to, anyway, you have all the instructions that you need to do this are in the first lessons. In lesson number 1, the powers, no, actually it was in the previous unit. So here in Introduction to Cloud Computer in AWS, here it tells you how to create the IAM user, and it tells you to give an Amazon Redshift full access, which we will not use. We'll use S3. But anyway, I just suggest you follow the whole thing as it's written here at lesson 2 from the previous unit, step 8. All right. So once you have that set up, it's going to give you your key and your AWS secret. And I'm in the wrong project. All right. And we are back at it. All right, so you just paste your access key right here and your secret access key. Drop the apostrophes, you don't need them, just straight up your key and ID and access key, your secret access key. I'm going to use a key over here so that we can access it through the config um, through the config parser. So I just added these key in brackets, and right here, let me move this over here. Right here, what I did is to get the access key ID, here the config, I added a .get, which specifies that inside the file that we already linked over here, we're going to go under the key, which is in the brackets, and look for this access key. And then right here, I did the same, so that it points them to underneath the key, the access key, and underneath the key, the secret access key. So don't forget to add this .get and the key over here. Of course, you can name this key whatever you want. Just make sure it matches with what you have right here. All right, let's continue. So the ETL basically has like all these incomplete functions that you need to fill out. And that's the main thing with this project. So here you start a Spark session, and I think this is already done for you. All right, so here in song data, you're going to get the file path from song data, and here we're going to use the os.path.join. And here we're going to use the input data, which this should point you to the Udacity DEND S3 that we saw here in the project datasets. And it's all the way in the bottom of the file. That's better. And all right, now we're talking. All right. So as you can see here in input data, I have it pointed to that S3 address, all right? And here, basically what I'm going to do, I'm going to go inside that folder, and then I wanted to look for everything that it's inside song data and follows this path. So remember that you had to know how many levels we had. So it was 3 levels for the song files and then the file. So this will give you all the files that you have in this address, basically. Here I'm printing them just to know what file am I working with, but you don't need to do this. And you're going to read each file from song data into a DF. Then you're going to extract the columns to create a songs table. So what columns are you going to choose? Well, the columns that you need based on your star schema. And for example, we're working on a song, so I know I need song ID, title, artist ID, year, and duration. And I'm just straight up choosing those from my DF. Right now it says to write songs table to Parquet files partitioned by year and artist. So Parquet files are a way of writing these tables in a columnar way, basically. And that is really optimized for this sort of analytical purposes and writing into the S3. But they're really easy to write. Basically, what we're going to do, we're creating the tables over here. So take into consideration the columns that we selected, we're going to write them right into a new table, but we're going to partition by year and artist ID, right? And then it says Parquet, which creates the Parquet files. And we're going to use a path that is going to point us to the same DEND. So in the output data, you can just point it to the, oops, got lost over here. Am I sharing the right thing? Sorry about that. And we're back. All right. So you can, in my case, well, actually, once we read the rubric, you will notice that you need to point all your new tables into a new folder called Analytics. So inside this Udacity DEND, the Analytics people can look inside this folder and see that here they'll find the tables that you already created for them in the star schema way. All right. So, and I'm going to write the table songs, and I'm going to use just override just to write over this table in case it exists. And we do the same for the artist table, we do this, we write the Parquet files, but since we don't partition by anything, we can miss that part partition. So this part created the song tables and the artist tables. Now about the log data, you follow the same approach to get each file. You read it back to that data frame. First, you're going to filter everything by next song, and you can use this indexing, which is really, really easy to use in pandas. And then you're going to extract columns for users table. So I think here I was supposed to write users, and I messed up, but sorry. So I have the user ID, first name, and all of these columns are taken from these data sets. As you can see, we have here the user ID, and what I'm going to do, I'm going to write them as I found them in the file, but I can use an alias to write them the way I would like to have them in my tables. For example, over here, I would like to use an underscore, whereas the original file had it with a camel, an uppercase, lowercase way. Nope. That will create an error because I was going to open these twice. All right. So I've done that, and now I'm going to write so this is what I'm doing here is basically selecting all the columns from the files that I already loaded in the data frame, and just making sure to change them or use an alias that I would use in the table. All right. Now I'm going to write the Parquet the Parquet file the same way I did with the rest. And now we're going to start transforming these data. So it says to create a timestamp column for original timestamp column. So I'm going to create a user-defined function, get timestamp, and it's up to you to figure it out. But remember that it's in epoch time, so most likely you will need to convert it to integer divided by 1,000, and that will give you the timestamp. And the way you introduce it into DF, just as we saw in lessons, is with column function. We're going to create this column named timestamp, and we're going to basically apply the function that we defined to all the elements in the TS column. All right, we're going to create a datetime, which is basically the same, but we can use this function datetime from timestamp. All right, and basically takes the integer divided by 1,000, and then we apply the function. And we're going to create this column with the same function with column. We're going to apply it to each and every element in the TS column. All right, so this is a little bit hard, but it's basically need to understand the Lambda lesson and how the datetime from timestamp will help you. And what I suggest you do is just Google how epoch time works. That's EPOC, and how can you transform it to a timestamp into a datetime to create a datetime column. All right, now to create a timetable, we do exactly the same. From this DF, you select the columns. If you want to keep the same name as a column, just write down the name. If you want to extract the hour, you can use the hour function, but don't forget to use an alias if you have a different name in the file, the data frame, that you will have in the table. All right, day of month, I get it, week of year, then the month, the year, the date format, and that's going to serve as our weekday. Then we write the Parquet files the same way we've written all the others, and this time we're going to partition them. And then we move on to the next, which is we're going to read in song data to use for the song plays table. So the song play tables, most of the info that we need will come from this DF that we already worked. But what we're going to do is here we're loading our song files into this song DF, all right? And we're going to join that DF, the previous DF with this song DF, and we're going to use the dot join. And basically it's telling, okay, join this data frame with this song data frame. And make sure to join them so that each song in the data frame matches song df title. And make sure to join them at all the points that they do share in common, that they have in common, such as artist, length, and I think that's it. All right. We're using a left outer just to keep everything from our user, even though they are not hearing any artists. So in case if a song is missing from the user's data, or if an artist is missing from the user's data, maybe because they haven't heard any songs, we don't want to lose that user in our data frame. That's why we use the left outer. And then from that join data frame, we're going to select the different columns such as timestamp and everything you need for the song play tables. And where do you know what you need? Well, you have it here on your schema. We need the song play ID, start time, user ID, level, song ID, artist ID. And these are the sort of things that we are selecting. Timestamp, user ID, so start time, user ID, level, song ID. And if the name that we use in the file doesn't match the one they want, like in the table, such as the user ID, we need to use an alias, right? And we keep going. And finally, we write the tables in a Parquet file. We're going to partition by year and month over here. And that's basically it. That is the project. Don't forget to use the output data. So once you're done with this, the only thing you're missing is you need to run the file here in the terminal with the Python etl.py, and then it will take a long time. I'm talking about maybe an hour because it has more than 10,000 files, and you have to write your README file where you specify like why do we need this star schema, what are some SQL queries that you can use in this star schema, and let me see if there are any other requirements. Yeah, that's basically it. Like, what's the purpose of the database? How does star schema help us? How does ETL pipeline help us? And what queries could you use for song play analysis? So don't forget to check the rubric just to make sure you're going over each point. For example, here the file tables need to be written in Parquet files in a separate analytics directory. So that's why I specify in the output an extra folder for all my Parquet files to reside on. And that's basically it. That is the project. I think I gave you like a big overview on what you have to do. Just make sure to understand where are you getting your different columns. If you need to change any column names. And I think that's it. All right. So let me know if you have any further questions that you need me to go over so that everything's clear with the project. And just keep progressing through your lessons. Make sure you spend time each day, preferably, working on the projects, and let's keep going. All right. So congratulations to everyone that's been progressing through the course. And don't forget, you can schedule a one-on-one meeting with me. You can write your queries directly in the study group or DM me, and have a nice weekend. All right, guys. See you soon.